So where do you place your meters? Now, obviously, you can't be out in the collection system at every manhole when there's a rain event. But consider the data that we've collected thus far and it's stored in our database, and we can then query the database. Where are our legacy problem areas? Namely, where there have been wet weather, basement backups, where there have been SSOs, that sort of thing. History comes to play. And what is the frequency of those? Where are the source receiver hotspots? Source being the watershed, contribution of groundwater. The receiver is the laterals and mains. And the hotspots are where those two systems are in close proximity. How does the watershed behave? Whereas it drained away in a few hours 30 years ago, now that water stays around for days. Where street flooding didn't used to exist, now it does exist under varying conditions. The change in watershed behavior can indicate where it takes place, where it's likely that the groundwater could enter the sanitary system. What are your manhole evaluations saying? Is there debris in the manhole which would indicate that there's a breach or a problem in the integrity of the sanitary lines? And how, of course, are the two collection systems, how are they designed? Is there enough capacity to, reserve capacity to drain away the stormwater if it gets into the sanitary lines? And is there adequate stormwater drainage? In every case, I'll say that, again, that if you remove groundwater from the sanitary lines, likely as not, you need to look back at, to fully accomplish rehabilitation, you need to look back at what the capacity of the storm lines are. So, whereas traditionally meter placement is done at key watershed points in your collection system, and generally there are 20,000 to as much as 40,000 feet of main upstream of a metering point. In my case, I said I had to find a better way. So I thought that I could design a different metering system that allowed me to get more meters in a smaller area and get more, a better idea of how the specific areas of the collection system behaved. Now, and this was done prior to doing video cam work or smoke testing, that sort of thing. So this picture is done in Global Mapper. This is a Tiger file, same type of files that the GPS systems use to tell you where you need to go. And you can overlay portions of your collection system. And this area is the same area of the slide before. We developed a metering deployment plan. And deployment simply means to set out your meters. And we clustered the meters in relatively confined areas, such that if we found areas that didn't respond to wet weather, we quickly moved those meters out of that area. Often it's as important to find where the collection system doesn't respond as it is to find where it does respond, so that by concentrating in the areas that are very responsive, particularly in the early parts of the rain event, you're more likely to confine the response area to smaller and smaller regions.